G'day viewers, and welcome to Computer Networks. I'm David Weatherall and I'll be your host for these lectures. And in this first segment, we're going to talk about some goals for the course, what you'll learn by going through it, as well as some of the motivation for why you might care to study computer networks in the first place. So this picture here describes our usual view of the network. You're all probably familiar with using clients, computers, that make use of the internet, and you know that they talk to servers over the other side of the network. What's much less visible, what most of us really don't have a good sense of, is what goes on in here, inside the network. And that is exactly the focus of this course. So if we think about networking courses, there are roughly three kinds of topics which are covered. At the bottom layer, there are communications courses, and these courses are all about how we use signals to carry information in bits across networks. Building on this layer, there are classic networking courses, such as those that tell you how the internet operates. These courses are mostly about how packets are carried across networks. And at a higher layer still, distributed systems courses tell you about the different kinds of apps or applications which can be built on top of networks and make use of their services. The ground we're going to cover is here. That is to say, we'll provide you with a classic networking course which talks about packets and the internet, but we'll also do a little bit of communications and distributed systems so that you understand how the network builds on communications, how bits are carried across networks, and also the kinds of things that applications can do on the top of networks. Okay, so we really have two main goals for you in this course, and I'll go over each of them in turn. Our first goal here is really for you to simply learn how the internet works. And by that I mean for you to gain a deep appreciation of what happens, for instance, when you browse the web, what really goes on underneath. Clicking on a link is a fairly simple action, but actually there's a surprising amount of machinery that exists below it to support that kind of operation. And in the course of understanding how the internet works, we're going to learn about many acronyms that you've probably already heard of. Things like TCP/IP, the DNS, HTTP, NAT, VPNs, 802.11, and so on and so forth. Many other acronyms too. I expect that you've seen a lot of them, and what we'll go over is we'll do much more than tell you what they mean. We'll give you a sense of how they operate and what their purpose is and why they even exist in the first place. So I'm going to go over each of those points a little bit more and give you a little more detail. So first of all, in terms of learning about the internet, why would you care to learn about the internet? Well, there are several reasons. One is simply curiosity. The internet's a very important artifact. You might be curious as to how it works. Since it's an important artifact, it also has a big impact on our world. I'll go over each of these points in a little more detail. That's what this little symbol means, more coming. And a third reason you might care to learn about the internet is simply job prospects. There's a lot of growth these days in engineering and computer science related jobs for which networking is an important component. So having a deep understanding of networking techniques and how the internet works can definitely be good for your job prospects. Okay, so let's talk about curiosity and the internet a little more. The internet really had very humble beginnings. This is what it looked like around 1970 when it first started, and at that time it was known as the ARPANET. And you can see here is the original 4-node network configuration, the topology. Look at that. And over time you can see that it quickly began growing to this other network in the middle, and then to this slightly larger network as it grew. Well, that was a while ago, around 1970. Here's something that's closer to where we are today. This is a visualization of the internet in 2005, around 2005. And by this time, the internet has turned into an everyday institution. It's something that nearly all of us use. We use it at work, at home, and while we're on the go. Now, actually, no one knows what the internet looks like anymore at this scale. This picture really is a visualization that's based on just a data set that's been gathered to give a good approximation of what the internet looks like. And you can see it looks more like a star chart with millions of links in there. So it's really quite an amazingly complicated structure nowadays. Another reason why you might care to learn about the internet is the tremendous impact that it has on our society. So the internet is really an enabler here of societal change. And you can see this in some of the ways that we already use the internet today. The internet provides very easy access to large amounts of knowledge by systems such as Wikipedia. Previously, that knowledge could be very difficult, time-consuming, or expensive to obtain. The internet allows us to undertake electronic commerce with systems such as PayPal, with really very little friction, so that we can buy and sell goods across the internet very easily nowadays. And the internet's even changed the way that we meet people with various systems and the way that people interact through networks. And the internet also provides us ways of communicating without censorship across even international borders. So it's changed the way that people are able to communicate. This is really a huge impact it's having on the world. You know, we might add to this list education, because the internet now, with systems such as Coursera, is really beginning to have a very significant impact on how we educate people. As well as impacting society, the internet is also having a large impact on the economies of the world. Really, you could think of the internet as an engine of economic growth. And these examples I've given you are all examples of business models that didn't exist before the internet. They didn't really make sense without the internet. So Google, as you probably know, runs using a business model of advertising sponsored search. This is something that's become possible because of the internet. For other stores, such as Amazon, Amazon operates with it's an online store, of course, but it also operates using a long tail model where it's able to sell a very large number of goods. It has an inventory which is much larger than you can really fit in any one reasonable physical store for people to wander around. So it's a different model. Online marketplaces such as eBay enable buyers and sellers to come together quickly, even though they're in very different physical locations. And even more recently, there's a great deal of interest in crowdsourcing systems such as Amazon Mechanical Turk, which can allow many people spread in different areas to all contribute to one task in ways which really weren't possible before. So the internet is having a tremendous impact on the way we do business. Okay, so that's a little bit about why you might learn about the internet today. The other main goal of this course is for you to learn the fundamentals of computer networking. And that is to say, to understand the hard problems that computer networks need to solve, and the design strategies which have proven valuable for solving these difficult problems. Now, it may be a little more difficult for you to appreciate why you would care to learn about the fundamentals of computer networks. Why should you bother, as opposed to learning about how the internet works today? Well, there are several reasons. The fundamentals are going to apply to all kinds of computer networks. We might talk about Wi-Fi a lot, just because it's a network technology that many of you see. And we might not talk about satellite networks, for example. But many of the fundamentals we learn about computer networks will also apply to satellite networks. So you're learning a little extra. You'll be able to transfer your knowledge to other kinds of networks. Much of this material is actually intellectually interesting. There are some thorny problems for us to solve, and I'll give you an example of that in a moment. And perhaps the most important reason you might care to learn about the fundamentals is because of change and reinvention. The internet is not static. It's continuing to change and evolve. And understanding the fundamentals gives you long-term knowledge which will help you understand the internet of the future. Knowledge about the fundamentals is knowledge that doesn't get outdated over time. Okay, so let's just talk about some of that in a little more detail. This slide just talks a bit about some of the intellectual interest you can get from the fundamentals. You know, just as an example of a key problem in networking, a key problem is reliability. If you're sending a message across the network to your bank, it's not acceptable for that message to be altered so that the wrong message arrives and you think that was what was sent. That wouldn't be good. Similarly, it's not acceptable if there's some failure in the internet somewhere for that to prevent you from getting to your bank, if the failure is not really on the path. Well, you know, all of these things can happen. Messages can get corrupted as they go across the network, so we're going to have to do something about that. Failures happen all of the time in the internet. Actually, the internet is so large that some parts of it must have failed right now. Yet we want the remainder to work seamlessly. Well, how are we going to do this and provide reliability? Actually, if you think about it, it's quite a thorny problem. Every component in the internet can fail, so we want to be prepared for that. Yet any mechanism we add to handle that can also fail because it's just more mechanism. So you can see the catch-22 here. Luckily, some clever solutions have been devised, and we'll learn about them during the course, that provide fairly high kinds of reliability. For instance, we'll learn about codes which can detect incorrect errors, and also routing strategies which can route around the failed components of the internet. And reliability is just my example, the one I chose to talk about here. There are other deep problems that we'll look at in networking during the course. Another example one is about network growth and evolution. Imagine trying to design a system to be able to accommodate applications that you haven't even thought of yet, and to be able to grow and get 1,000 or 1,000,000 times larger than the initial system. This is really hard. Well, there are some useful techniques that we'll come up with here. And by the way, the numbers here, these are section numbers in your text which you can consult. There's no need to go off and do that for this slide here. This is really referencing material that we'll cover throughout the whole course. So don't jump into all of that yet. Just start with the introductory material. Another difficult problem, just to put a last couple on the table, is the allocation of resources such as network bandwidth. That's really what networks are doing, providing bandwidth to the different users. But if you think about the internet, many people are using it. The users are coming and going as some people surf the internet or stop surfing the internet and so forth. And we're going to need to design mechanisms which can handle all of this different churn and still do a good job of giving whoever wants bandwidth the bandwidth that's available in the internet. This poses some difficult problems. Security is also another difficult area. It actually turns out to be very difficult to design an internet which is very open and easy for everyone to use, which is key for innovation and is an important part of the internet, yet at the same time is secure in the sense of being very difficult to abuse, so that malicious parties can't very easily undermine the actions of other parties. So there's a big tension here, and we'll learn about some of the techniques. Okay, but the other reason you might care about to know about the fundamentals is really the reinvention of the internet. Now, if you think about it, you realize that the internet is constantly being reinvented. The internet is growing tremendously over time, and there are also lots of technology trends. Both of these changes are driving upheavals in the way the internet is designed and the way the internet is used. So the upshot here is that today's internet is actually quite different than yesterday's internet in many respects. Tomorrow's internet is going to be different again. Yet for both of them, the fundamentals are going to remain the same, and they will help you understand what's possible in computer networks. That's why we want to tell you about them. Just to go into that in a little more detail, this graph shows you the growth of the internet in terms of the size. And you can see here in the early 90s we start with maybe 1 million hosts, and up here we've gone up to maybe 1 billion hosts. So wow, look at that. That's a factor of 1,000 growth in just the size of the internet, which is really pretty impressive growth if you come up with designs and you want them to be able to work through that evolution. But more than that, we've also seen many upheavals in the internet over this period. And I've listed here just some of the growth and technology drivers which are causing those upheavals. You can see, for instance, when the web emerged, this led actually to the creation of what are called content distribution networks to satisfy the enormous demand for getting the same web pages to many different people. As the content of the network changed and we shifted to digital songs and videos, there was an upheaval in which we shifted to and explored different peer-to-peer methods for sharing files. As the cost per bit of sending information over the internet has fallen, we've switched increasingly to voice over IP calling, so that functions which were traditionally part of the telecommunication network, the telephone network, have been incorporated into the internet. This one's about growth, many internet hosts. This has actually driven a change where we're going to have to update all of the basic internet protocols, and we're in a transition right now to IPv6. But you can see, while this one's about growth, pure growth, many of the others aren't. They're really upheavals caused by technology trends and changes in the way we use the internet. And finally, just to put out there, advances in wireless have led to many more mobile devices, and these devices stress the internet protocols in different ways that we'll see a little bit of during the course. Okay, and finally, just to close this segment, I want to point out one thing which is not an explicit goal of this course, and that's to provide you with IT job skills, such as, for instance, Cisco certification material to help you configure networks. That's not because this is not an important skill, it's because some of this material can change fairly quickly over time as new equipment comes and goes, whereas what we want to give you really is long-term knowledge which will remain relevant in the future and help you understand the internet. Now that's not to say that this is purely an academic course, however. Much of the material you learn will really be very practical about how the internet works, and we'll also experiment a little bit with some hands-on tools. So you'll get a good sense of some real-world stuff. Okay, so on with the show.